Hello, I'm Dr. Kode Jaya Prakash, working as Senior Assistant Professor in Department of Mechanical Engineering at VNR VJET. So today I'm going to discuss about the post-processing techniques for polymer and metal additive manufacturing. So first of all, what are the post-processing techniques which are required for polymer 3D printing? And then after that, what are the post-processing techniques which are required for metal additive manufacturing? I'm going to discuss in the today's topic. So first, when you're going to see about what is the post-processing techniques for polymer metal printing. So first and foremost thing is that support metal removal. So support metals are because supports are especially used for overhanging portions for the parts to be printed. If the parts inclination is more than 45 degrees, then obviously support structures are required. So these support structures for polymer printing can be easily removed with the help of hand tools or with the help of different simple tools. So these supports are also called as easily breakable supports. So we can remove with our hands and supports suppose if the supports are there in that axis of proportions also, we can able to use the separate tools to remove the support materials. So these support structures can be removed with the help of two categories. So that is support removal with our hand tools or different tools. And also second thing is that dissolvable supports means that completely if you want to remove the support lay marks also can be removed if you are going to dip that part in the isopropyl alcohol solution. In the isopropyl alcohol solution, it is completely that layer lines also is going to be removed completely. So this is the standard procedure of support removal for polymer printing. And coming to the case of sanding and polishing, if you want to remove the layup lines or if you want to remove the rough surface portions on the surface of the additive manufacturing part, so then sanding requires especially that is a sand grit paper. So different because based upon the roughness on the surface of the parts which are printed, based upon that we need to select the grit numbers, grit either 100 or 50 or 200. Based upon that roughness, we need to select the proper grit number, and we are going to rub it on the surface of the part, which is where you can find the rough portion. Based upon that, the roughness is going to be completely removed. And also polishing. So these polishing techniques are it is the most common technique, especially which is required to improve the surface improvement. So completely, if you want to make it as a shiny surface, then we are going to apply this several sort of polishing techniques, like different sort of pastes, different sort of applying of the pastes, and using of soft cloths and rubbing it a number of times. So this sort of print irregularities is going to be completely removed on the layers. So uniform surface texture is going to be improved with the help of this sanding and polishing techniques. And coming to the case of next other technique is called as tumbling. So this tumbling, as you can see, there's some abrasive materials is also be there. So inside portions, because the part which is having the inside portions, if you want to do the finishing, so then this sort of vat containing a lubricant fluid with abrasive media is going to be used. And this tumbling is a automated subtractive method, so where multiple parts can be done simultaneously, so where this roughness can't be finished inside the parts. Especially for this reason, this tumbling is going to be used. But because if you want to use this sort of technique, most of the things are expertise is required to prepare the parts, and what is the required abrasive media to be used, and what is the time to which it should be processed. So all these things should be keep in the consideration, and based upon that, this tumbling is going to be used. And abrasive blasting are also called as a sand blasting. So this is also a subtractive post-processing method. So where this abrasive material is going to be imposed with a high pressure on surface of the parts which are printed. So based upon that, this roughness on the top of the surface of the parts is going to be removed. But this abrasive material is very smaller than the tumbling, previous process which are discussed. And this is also less effective on parts which are too rough. So only for the medium sort of parts which are rough in nature, only those parts only can be removed. Otherwise, we should go for the process of the tumbling. So next is CNC milling. So CNC milling is obviously it is a subtractive process, and sometimes based upon the requirement, if you want to mill at the edges, at the corners, then you are going to use the milling cutters. So these milling cutters are especially used to finish at the completely edges. So then next thing is the chemical dipping. So this chemical dipping is also called as aid dipping, and because we are going to completely submerge the parts in the chemical bath. And such as, so the solutions we are going to use is lye solution and sodium hydroxide, and some sort of solutions are going to be used, and they should be, so expertise should be there. So how much time it's required to dip it, and for what sort of roughness, and utmost care should be taken to avoid air bubbles which are going to be trapped inside the parts which are printed. So this process is ideal, especially only for complex geometries, as the chemical bath treats are all the surface submerged parts are going to be done simultaneously. So next one is called a filling, because though if you go for finishing, there will be some minute gaps. So for that, epoxy compounds should be there, can be used, or thick sort of adhesive compounds should be used to fill those gaps, to make the part lustrous and shiny finish. For that, this gap filling also should be there, and these fillers can be used with the help of a paste, and also like wood fillers, and also sometimes spray fillers are going to be easily to apply, but provided only the thing is that thin surface covering and resulting in a rougher coating, because the utmost care should be taken when you're going to use for the fillers. And next thing is that brush coating. So liquid coatings are generally very widely in the metals such as paint, varnish, resin, or even plastic. So especially this sort of, although the surface smoothness may be inconsistent, due to that, brush strokes and choosing a metal with proper viscosity can avoid these surface irregularities. So then some sort of minute to medium level of surface irregularities can be overcome with the help of a brush coating. And spray coating, it is a wide range of scalable post-processing technique, and it is going to offer a number of viable methods ranging from DIY products to the robotic automation. We can able to perform spraying by manually or with robotic automation. And most of the huge variety of materials such as paint, varnish, and resin, plastics, and rubbers also can be finished. And dip coating. So this dip coating is going to be done in 5 stages. One is immersion, completely it should be immersed. So the 3D printer part is completely immersed in a vat or metal which is with a constant speed, and then is going to be startup. The part remains submerged for a specific time based upon the type of metal we are going to be used, and then deposition. So the part is removed at a constant rate as a thin layer of the metal is going to be deposited, and then excess metal is going to be drained, and then followed by the we need to dry it for the evaporation. So as the coating sets, the solvent is going to evaporate from the material, leaving a solid film. That is called as dip coating. And next is annealing. So annealing is especially used for a heating, sort of stage, and to improve its molecular structure. Means that molecules are unorganized and weaker if you are going to use it directly. So to strengthen the part, so its molecular level is going to be heated to its glass transition temperature below its melting point. So this sort of improving of this sort of molecular structures can be able to be obtained in the stage of annealing. And vapor smoothing. So vapor smoothing is also a chemical process of smoothing, especially for the parts which are exposed to vaporized solvents and in an enclosed chamber. Similarly to the chemical dipping, the correct solvent should be used for the concerned material. So here solvents can either be heated to a gaseous state or vaporized by ultrasonic misting. So the part which is going to be used is going to be exposed with a vaporized solvents for a specific length of time. So too short and the part is not adequately smooth. So too long, the part can deform and become brittle. So some sort of experience is going to be required based upon the part and based upon the material which are supposed to be used. And now coming to the case, so all this process comes under for the polymer post-processing techniques. But now, what are the techniques which are required for the to post-process metal 3D printed parts? So one is the part unloading. So unloading of the part is going to be very important role, and followed by depowdering. This removal of the powder on the surface of the part which is printed, and then followed by heat treatment, and followed by part cutoff and support removal, machining, surface finishing, and inspection. So this is a sequence of procedure to post-process the metal 3D printed parts. Coming to the case of part unloading, so once this additive manufacturing of the metal is going to be done, it is surrounded by unmelted powder all around. So this unmelted powder has to be separated, and so can be separated with the help of a vacuum powder conveyor module. Is going to prevent with so this sort of technique is going to prevents the human contact from the powder, because the powder granules are too fine. So because if it enters into our mouth or nose, it is harmful. So utmost care should be taken if you want to remove the part unloading. And depowdering. So this depowdering is the process of removing the trapped metal powder inside the printed part. You can see this inside the printed part, and this can be removed with the help of mechanical vibration, or air is going to be used to push the powder out of the part. And followed by heat treatment. So heat treatment is especially used to improve its mechanical properties. So to relieve the internal stresses, to reduce the internal thermal stresses is going to be used. And heat treatment is going to be done before separating the parts from the build plate in order to eliminate warpage of the parts. So in addition to the heat treatment, parts can be subjected to hot isostatic pressing, so wherein high pressure and temperature are going to apply simultaneously to make the parts stronger and denser. So this is the utmost important task for the heat treatment for the metal 3D printed parts. And coming to the case of part cutoff, because removal of the supports can be used by manual chiseling process. So it's only if the supports are weak and minimal, then this option can be used. Otherwise, you need to go for bandsaw. So bandsaw cutting requires extra material around 5 mm to be printed to compensate for the blade thickness. And also, if you want to thin finish is required, then you need to go for iridium. So these are the three different techniques which are going to be used to remove the supports. But whereas in FDM can be used with the help of hand tools or simple tools, and also the isopropyl alcohol solution, we need to dip it. But here this metal supports are in the form of lattice structures. Because of that, if the supports are weak, then we can go for manual removal with the help of small hammers and chisels. Otherwise, you need to go for bandsaws and wire EDM. And then coming to the case of support removal, so this is the manual chiseling is going to be done with the help of this separate sort of hammers and the tools, and followed by wire EDM is going to remove all the internal supports, and CNC machining, and also for these are the different techniques to remove the support materials for the metal 3D printed parts. And next is the call of machining, because sometimes it is required. The features could be in the form of threads or for fastening of the holes. So it should be machined if it is required. Especially the part specific jigs and fixtures are manufactured to clamp the part. For that, the machining is required. And surface finishing. So depending on the kind of finish, that is if you want to get a aesthetic look, then the surface finishing is required. And you can use that vibro tumbling, and also for formed by short blasting, and abrasive flow machining, and followed by plating and polishing. So these are the different surface finishing techniques to obtain this to make the additive manufacturing part as good as aesthetic look and for surface finish. And coming to the case of inspection, after all these techniques, then we need to see the inspection. So inspection is the final stage of the post-processing for the metal 3D printed parts. So that can be done either in the different stages. One is dimension inspection with the help of a vernier calipers to make sure that dimensions are meeting as per geometrical dimension and tolerances standards, and depends upon the measuring instrument which is chosen. and then followed by mechanical inspection. Mechanical inspection means we are going to estimate its mechanical properties, so whether the values are meeting as per the materials data sheet. Means that we are going to make that as a specimen, and then we need to test the tensile, shear, and also after that how the microstructure is going to be obtained because of facing all these things. So then based upon that, mechanical inspection has to be done as per the values which are going to be done in the data sheet. And structural inspection, because there will be some internal defects, so those internal defects also can be identified using NDT methods, non-destructive testing methods, to make sure that proper, so 3D printed parts, the internal defects also, which can't be seen through our eye, also can be done. So one such method is called as a dye penetrant test. So they are going to impose the dye on the surface of the part which is printed, and after leaving it to some time, you can find this deposition. Means that so wherever the dye is going to be passed in that area, means you are going to have some cracks or defects. So in this way, you can able to identify the defects which can't be observed through a naked eye. And also ultrasonic. So ultrasonic waves are going to be propagated. So on the surface of the workpiece, so wherever the echo is going to be stopped, on up to that portion, you can able to see the defect or crack. And also CT scanning. So that's CT scanning is also one more the technique, so to identify the defects. So these are the different sort of inspection, how we are going to perform inspection and mechanical inspection, followed by identification of structural defects. So thank you. So thank you for this post-processing session of the polymer and metal 3D printed parts. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.